Have you ever wondered what would happen if there was gravity in space? Gravity, a concept as fundamental to our existence as the air we breathe, is an invisible force that pulls objects toward each other. On Earth, we experience gravity every day. It's the reason we stay grounded, why an apple falls from a tree, and why the moon orbits our planet. But when we think about space, we often picture astronauts floating around in their spacecraft, free from the pull of gravity. This paints a picture that space is a place where gravity ceases to exist. However, this isn't entirely accurate. In reality, gravity is everywhere, even in the vast expanse of space. The force of gravity extends infinitely in all directions, pulling everything towards everything else. However, the strength of this force decreases rapidly with distance. This means that the further you are from a celestial body, the less you feel its gravitational pull. So why do astronauts appear weightless in space? Well, it's not because there's no gravity, it's because they're in free fall, constantly falling towards the Earth, but also moving fast enough sideways to miss it. This is what we call orbiting. The same principle applies to the moon orbiting the Earth or the Earth orbiting the sun. They're not free from gravity. In fact, it's gravity that's keeping them in their orbits. The moon, for instance, is always falling towards the Earth, but it's also moving sideways fast enough to keep missing it. So, when we talk about gravity in space, we're not saying there's no gravity, we're saying that its effects are different than they are on Earth. The gravitational pull of celestial bodies extends across space, but the vast distances involved make its effects feel less pronounced. So in essence, space isn't entirely devoid of gravity, but let's delve deeper into this fascinating subject. To understand what would happen if there was more noticeable gravity in space, we first need to appreciate how gravity currently operates in the cosmos. Gravity, as we've come to understand, is a force of attraction that exists between any two masses, any two bodies, any two particles. It's what keeps our feet firmly planted on the ground, and it's what keeps the Earth and the other planets tethered in their orbits around the Sun. Quite like an invisible tether, gravity pulls planets into a curved path around their star, keeping them from careening off into the cosmic void. But it's not just our solar system that's held together by this unseen force. Gravity is also responsible for moons orbiting planets, and even on a larger scale, it governs the movement and interaction of galaxies. It's the glue that holds the universe together, the cosmic ballet director guiding the pirouettes of celestial bodies. And gravity doesn't stop at just influencing physical bodies. It also has a profound impact on something as intangible as light. Yes, gravity can bend light. This phenomenon, known as gravitational lensing, occurs when the path of light is distorted as it passes through the gravitational field of a massive object, like a galaxy or a black hole. The light doesn't change its speed, but its direction shifts, causing an effect similar to viewing an object through a magnifying glass. In the seemingly endless expanse of space, gravity is the invisible puppeteer, pulling the strings that dictate the motion of celestial entities. It's the underlying principle that governs the cosmic dance of stars, planets, moons, and galaxies. Without it, the universe as we know it would be unrecognizable, a chaotic mess of celestial bodies hurtling aimlessly through space. Now that we understand how gravity behaves in space, let's ponder over the hypothetical scenario of increased gravity in space. Now, let's journey into the realm of the hypothetical. What would happen if there was more noticeable gravity in space? Imagine a universe where the gentle tug of gravity is not so gentle, where its invisible hand reaches out with a stronger grip. This is a universe where gravity, the cosmic glue holding everything together, is more potent than we're used to. What would this universe look like? Firstly, let's consider the orbits of planets and moons. Right now, each celestial body moves in a delicate dance shaped by gravity's pull. But if gravity were stronger, this dance could become more of a mosh pit. Planets and moons might be pulled from their established orbits, potentially causing catastrophic collisions. The serene ballet of our solar system could turn into a chaotic demolition derby. Next, let's turn our attention to the stars and galaxies. The birth of a star is a cosmic event dictated by gravity. Clouds of gas and dust collapse under their own weight, igniting to form a glowing beacon in the darkness. But with stronger gravity, this process could be dramatically altered. Stars might form more rapidly, burn more intensely, and die more violently. Galaxies, too, might evolve differently, clustering more closely together and potentially merging more frequently. The night sky would look quite different from the one we know. the propagation of light across the universe could also be affected. As Einstein's theory of general relativity tells us, gravity can bend light. This is why we can observe gravitational lensing, where the path of light from distant stars and galaxies is warped by the gravity of massive objects. If gravity were stronger, this bending of light could be more pronounced. Light from distant corners of the universe might never reach us, robbing us of our ability to observe and understand the cosmos. Furthermore, life as we know it could be fundamentally different. The stronger gravitational pull could affect the development and evolution of life on other planets, if such life exists. Even our own biology could be different if Earth's gravity was significantly stronger. So this hypothetical universe with increased gravity wouldn't just be our universe with a little extra weight. It could be a universe where the rules of cosmic evolution are rewritten, where the dance of celestial bodies is more chaotic, and where our understanding of the cosmos is dramatically altered. Such a scenario paints a dramatically different picture of the universe as we know it. In today's thought experiment, we plunged into a universe with increased gravity in space. It's a concept that bends our understanding of the cosmos and defies the principles we're familiar with. So let's take a moment to recap what we've discussed and the implications of such a scenario. We began our journey by unraveling the enigma of gravity, which is the invisible force that binds the universe together. It's the reason why we stay grounded on Earth, why our planet orbits the sun, and why galaxies cluster together in the vast cosmic sea. Despite its ubiquitous presence, gravity is surprisingly weak compared to other fundamental forces, yet it's crucial in shaping the universe as we know it. Next, we explored how gravity currently operates in space. Contrary to popular belief, gravity isn't absent in the cosmos. It's just that objects in space are falling towards each other in a way that they seem to be floating. This is due to the principle of freefall, and it's what allows astronauts aboard the International Space Station to experience weightlessness, even though they are technically still under the influence of Earth's gravity. Then, we dove into the hypothetical scenario of increased gravity in space. If gravity were stronger, planets would need to move much faster to avoid being pulled into their stars, leading to shorter years. Stars would burn through their fuel more quickly, living fast and dying young. Galaxies could be denser and smaller, altering the very fabric of the cosmos. This scenario also highlighted the potential impacts on life as we know it. If Earth had a stronger gravitational pull, it could affect everything from our physical structure to the way we perceive time. Life might have evolved differently, or perhaps not at all. However, it's important to note that these are speculations based on our current understanding of gravity. There's still so much we don't know about this fundamental force. The universe is a complex puzzle, and gravity is just one of its myriad pieces. So, what's the gravity of the situation? The balance of our universe hinges on gravity. It's the glue that holds everything together, from the smallest atoms to the largest galaxies. Altering its strength could potentially disrupt this delicate balance, leading to a universe vastly different from our own. While it's a fascinating thought experiment, it's safe to say that we should be grateful for the gravity situation in our universe as it stands. Imagine the chaos if it were any different. So, next time you feel weighed down by gravity, remember that it's this very force that keeps our cosmic boat sailing smoothly in the vast ocean of space.